All right, this is part 7, which is your final step in your scientific method for your science fair project. And this is the most important part of your project. Now, all the parts are important, but this is one that's very special. This is where I've seen, not as a judge, but as an organizer for science fairs, I've seen science fair judges can look at a very well organized, very neat project, and it can, a conclusion and the results portion of the science fair project can cause it not to win, if that's what you're interested in doing with a science fair project, is winning. But I've also seen a science fair project that students have explained that things just didn't seem to go very well, the hypothesis was not correct, had a lot of problems, but during the results portion and the conclusion portion, they were able to very clearly explain what happened and why they think that happened. And they actually did very well in this, or in the science fair. And so in this portion, the results and the conclusion sometimes can be combined into one paragraph, but word of advice, you might want to separate these. So this first portion that you see here on the screen is the results. This is where you are looking at your graph, where you saw in part 6, or looking at your chart and explaining it using sentences, using words that will help you or help the person who is looking at your science fair board to be able to understand what happened. But it also shows that you understand what happened. So I want to circle or underline a few words that I think are very important in this results description. And this one doesn't follow the results that I showed you in part 6, which is the charts and the graphs, but you're going to look at some keywords. So looking at the example here, it says, from reading my charts and graphs, I know that plant group A grew an average, and we'll circle that word, of 40 centimeters with 100 milliliters of coffee. Plant group number 2 grew, should be no D in that, an average of 20 centimeters with 100 milliliters of water. The plant group that was given coffee grew 20 centimeters more on the average, there's that word again, than the plant group that was given water. This is where you're taking the measurements and you're averaging them together. This is where you're showing off those math skills. And if you're not sure how to do average, you might want to get the help of an adult or just do an internet search. How do you find the average of certain numbers? So I'm going to scroll down to the next part, which is, let me go back to here. So let's go down to the next part. The next part is the conclusion. So your results part is basically just writing out what happened based off of your graph. The conclusion part is where you start thinking like a scientist. And so it says to write down why you think your experiment turned out the way it did, and include if your hypothesis was supported or not, which means if you think that the caffeine or the plants that had caffeine would grow more, then you say my hypothesis was supported. If you thought the water would, then you would say my hypothesis was not supported. And let me tell you, from the very beginning when I told you about hypothesis, it's okay if your hypothesis was incorrect. Most scientists, if not most of their experiments, it never does support their hypothesis. But again, do not say, you don't want to say that I was right or wrong. Do not say that I was right or wrong. You want to say in the words, it was not supported or it was supported. So even when your hypothesis was not supported, you gain information about your topic. You're learning something. That is where you want to include what did you learn based off of what happened. Okay? And so the final part in your, the final part of your project in your conclusion, this will be an example. Okay, the example, just like I said before, my hypothesis was supported. The plants that were watered with coffee, which had the caffeine, grew taller than those that were given water. Therefore, some key words in there. Let me go ahead and underline those keywords. Therefore, caffeine has a positive effect. Okay, some more words that you want to use on the growth of pea plants. This may be due to the fact that caffeine is a stimulant. So this would probably come along in your research. The caffeine could have stimulated the plant to grow. And so these key words, what these science fair judges are looking for, what did you learn through this process? And what you're learning through the process, is more important than if you were correct, because most likely you're not going to be correct, and that is perfectly okay. And so this is what your results and your conclusion is going to be about. This is what scientists do mostly during a science experiment. They do writing. Let me go back to this and clear this out. They mostly do writing. They're writing about what happened, okay? So here are your key tips and things to remember when you're writing your results. Again, your results and your conclusion, let's separate them into two parts, two written portions. You can type it and put it on your board. You can also write it to put on your board. It's okay. It doesn't matter, just as long as your handwriting can be read. If you have very sloppy handwriting and you can't write it neat, it'll probably be best to type it and print it out. But these will be two portions that you put on your board. I'll add another video, or the last part of this science fair project demonstration will be some tips and what your science fair board would look like. And so this would be what you would do when your science fair project is done. So hopefully through these 7 steps to the scientific method, they have been very helpful to you, give you a little bit of an understanding of what to do and what order to do them in.